Welcome back. Let us continue our discussion of the zeroth law. We have said earlier that zeroth law considers the characteristics of systems which are separated by a diathermic wall, and a diathermic wall is a wall which is not adiabatic, which we allow heat transfer across it. So what we consider is a pair of systems. This is the basic experiment which we consider for zeroth law. Let us say that we have a system A and a system B separated by a diathermic wall. Because it is diathermic, it will allow heat transfer from one side to other as appropriate, either from A to B or from B to A, depending on the states of the two systems. Now we do the following experiment. We fix state of A to say A1, and for this fixed state of state A1, what we do is check whether there are states of B for which there is no heat transfer with system A in the state A1. Let us sketch simple state spaces for the two systems. This is the state space of system A, this is the state space of system B. Let us say this, if both are fluid systems, pressure volumes are appropriate, PA, VA, PB, VB. If they are not fluid systems, in general this could be some property XA, some other property YA of system A, and this is some property XB of system B, some property YB of system B. Let us say this is our fixed state of system A1. What we do is we experiment with various states of system B. Bring those states in contact with the specified state of A, A1, across a diathermic wall, and we may discover that there is one state here, let us call it B1, such that when A is in its state A1 and B is in its state B1, in spite of the separating partition being a diathermic wall, the heat transfer is 0. Now we come to the first part of zeroth law. So statement of zeroth law, part 1. This statement says that such a pair of state A1, B1, state A1 of system A and state B1 of system B exists. That means any two systems we take, bring one, say A, to a fixed state A1, then in the state space of system B there is at least one state, say B1, which will not interact by the heat transfer mechanism across a diathermic partition. That means even if heat transfer is allowed across that partition. Now some definition. This long winded way of saying, let us shorten it, saying states A1 and B1 are such that if they are allowed to interact across a diathermic wall, in spite of that wall permitting heat transfer, no heat transfer will take place. All this thing is shortened by saying that A1 and B1 are isothermal states. So we are defining the word isothermal. Another way of saying the same thing is A1 and B1, these are states of A and B system A and B which are in thermal equilibrium. So, here we are defining the words thermal equilibrium. So, when we say states A1 and B1 of the two systems A and B respectively are isothermal, which means that the two states are in thermal equilibrium with each other. It means the same thing, that if you allow system A in its state A1 and system B in its state B1 to interact across a diathermic wall, in spite of that there will be no heat transfer. And the first part of Zeroth law is the existence of such pairs of states. Thank you.